This time on Adventures in Science, visit Peru. Why? To answer the very difficult question of where Peruvian cities get their water. The capital city of Lima is surrounded by one of the world's largest deserts, yet millions of people live and thrive. How is this possible? Just like every person on the planet, citizens of Peru need water, and without it, they would perish. We have to figure out where their water comes from and whether there's a chance that this precious water will someday run out. To answer this mind bender, I cross the deserts, I explore remote trails, and I climb the icy Andes Mountains. Engage the gears of your brain. Off we go to Peru. Hey, welcome to Lima, the capital of Peru. Just so you know, Peru is in South America, situated between the Amazon jungle and the Pacific Ocean. The bustling city of Lima has 9 million people, making it the third largest city in South America. This city is so old, but like any city with millions of people, water is crucial. Drinking, business, sanitation, like toilets and sinks, all require water. Without water, this city and its people would crumble. Lima was founded about 500 years ago by a conquistador, Francisco Pizarro. Before Pizarro, this was the location of numerous Indian settlements. Despite the clouds that are almost always cloaking Lima, the city is surrounded by desert. In fact, the city only gets about a third of an inch of rain every year. So how does this compare to my hometown of Boston, Massachusetts? Boston gets about 40 inches of rain every year, over 100 times more than Lima. Lima just gets a little bit. With so little fresh water, how has Lima existed and thrived for hundreds of years? Seriously, where does Lima get its water? We can see a large river, the Rimac River, passing through town. And this is the major source of water for 9 million people. But where does this water come from? Nearby or far away? If the water source is far away, how do the folks in Lima know that the water sources are safe? By safe, I mean, how do they know that they can reliably get water today, tomorrow, in 20 years? And you know, Lima's not alone. The same mysteries exist for other Peruvian cities and towns. Where do these communities get their water, and how can they be confident that this water will flow every day? How can we use the power of observation and a bunch of curiosity to figure this out? Where should we start? How about we follow the rivers from the cities and towns to their source? The river's still flowing, and this means we have to go further upstream to find the water's source. we've curved our way across desert landscapes on up into the mountain town of Huaraz, Peru. We're at 11,000 feet. That's 2 miles above sea level. There are no cities in the United States at this elevation. A new location, we need information. Mission Control? Yeah, tell me about Huaraz, Peru.
Hi, Doc. Huaraz is the second largest mountain city in all of Peru. There are over 120,000 people nestled into the valleys and along the hillside. The Spanish founded the official city in 1574, but you are in a city that was once part of the Incan Empire. Huaraz makes most of its money through farming, but lots of people go to the city as tourists to see the mountains and adventure. There are several nearby rivers that stream out of the mountains, providing Huaraz with a continual supply of fresh water. Doc, this is Mission Control. Rain or shine, get after it.
Mission Control, thank you so much. This is cool information. Now, back to the task at hand. Where do Peruvian cities get their water? Our exploration has taken us to Huaraz, where the rivers flow through Huaraz. Clearly, the source of water is coming from further uphill. So what have we done so far? We've traveled hundreds of miles from Lima to Huaraz, a really long way. We haven't found the river's source, but if we go much further, we're gonna run smack dab into the soaring Andes Mountains. Formidable, inhospitable, cold, rock covered in snow and ice. Perfect. Off we go, upwards and onward. This is where the road ends, so now we follow rivers deep into the Andes Mountains. Note to self, by looking up valley, the sun is shining bright. There are no clouds. This means that rain is not the cause for all of the water flowing in our rivers. I followed the river so high in elevation and the air is super thin. You'll notice that this river's a lot smaller than the rivers that were flowing through Lima and Huaraz. But that's because in these mountains, each valley has its own small little river flowing downhill. Here's a great example of a small river coming together with a bigger river. Imagine if we have several of these coming together. Think we'd have enough water to supply, say, Lima? If each valley has a stream, and it's the collection of mini streams that make for big rivers, then something really important must be happening up in the valleys to create all this water. Let's find out from Mission Control how these valleys formed. Yeah, Mission Control, tell me about these valleys.
Howdy, Doc. It might seem strange, but the valleys that you are hiking through were once filled with ice. Right now, temperatures in those valleys are too warm for permanent ice. But 20,000 years ago, climate things were different. The entire planet was much colder. It was an ice age. It's so interesting that ice ages have chilled Earth several times over the past million years. Doc, it was so chilly right where you are that the ice in those mountains could grow downhill. These massive rivers of snow and ice called glaciers were so powerful that they plowed down valleys. It was the glacier that completely changed the landscape. Doc, this is Mission Control. Think on your feet and talk to you soon.
Mission Control, you're the best. Glaciers are huge forces in our universe. I bet you we could find evidence of glaciers bulldozing down through these valleys. Come, follow me. Check it out. We're so close to where the glaciers are today, we can almost reach out and touch them. But there's also evidence right here that the glaciers from the last ice age rode right down through this valley. Millions of years ago, This valley was nowhere near this deep, but it was the glaciers that scoured and gouged out rocks and soil to make it into what we see today. What a massive act of destruction. As these glaciers, these huge bodies of ice, pushed downhill, they picked up rocks and boulders by surrounding them, encasing them in ice. These rocks, buried in the bottom of the glacier, acted like the world's largest piece of sandpaper. Check it out. The cliff wall is way too big to be moved by the glacier. So instead, the rock was polished as the glacier rode on by. We call this glacial polish. If you see glacial polish, you know a glacier rode over the area. Let's get a little closer. If you look up close at glacial polish, sometimes you see scratches. These scars are caused by individual rocks in the bottom of the glacier carving out the rock. If you want to know which way is downhill, follow the scratches. What we just saw is perfect evidence for an ancient glacier. This wall of ice is absolutely huge. Right now, we're at the snout, the very bottom of a glacier that's here today, and it's melting. Rivers are literally flowing out from under the glacier. It's the ice, frozen, locked in the glacier, that's melting and making these rivers. It's the meltwater from hundreds of these glaciers that flows downhill, at first in small streams, that then collect into big rivers that provide faraway Peruvian cities and towns with fresh water. We found the water's source. Now, it's time for a word from our sponsors. Hi, do you ever flush your toilet? Do you ever get thirsty? For half the world's population, fresh water comes from the high mountains like the Himalayas, Andes, and Rocky Mountains. The story of how these mountains work is fascinating. Water evaporates from our oceans. Moisture fills the air. When this air flows into the cold, high mountains, it snows out. Yes, it does. Mountain snow melts, the water flows down our streams to us, and it's this water that we use every day. The high mountains, they bring life to our world. Whoa! Fresh water's in high demand all over this planet. Human numbers have swelled to over 7 billion people. Where do many of these people get their drinking water from? The high mountains of our planet. So we have our solution. Where does Peru get its water? From the melting glaciers. But our story is incomplete. How do we know that these glaciers that are melting so fast will keep providing fresh water to Peru? So why is this question so pressing? Because it's winter and the ice is melting. Tell me, what's the temperature?
Hello, Doc. It's 45 degrees.
Whoa! It's that warm and it's winter. Shouldn't it be cold and harsh in the high Andes Mountains? But it's not. On top of that, wouldn't you expect the melting to be even greater during the summers? How can these glaciers exist when they're melting all year round? Time for more exploration. It has gotten cold. The higher on the mountain we've gone, the more the temperatures have dropped. Tell me, what's the temperature?
Hello, Doc. It's 27 degrees.
Yep, a lot colder. The important thing is the temperatures are so cold that the snow is frozen solid. No more melting. The fact that the air is colder the higher that we go explains why the high mountains of our planet are covered in snow. The key is that when it snows here, it builds up, it accumulates. That's why we call this area the accumulation zone. It's pretty neat that glaciers have both areas that melt down low and areas up high that accumulate snow. But wait, part of this isn't adding up. This glacier has been here for thousands of years. And yet, why hasn't the accumulation zone grown and grown and grown? And then, why hasn't the melt zone completely melted away? We were just down there and we saw it melting in the middle of winter. With so many centuries of melting, the melt zone should be long gone. We're missing part of the story about how glaciers work. Can we take all that we've observed and create a testable hypothesis? By hypothesis, I mean our best guess as to how things work. If our explanation doesn't fit into all we know and have seen, it's probably not a good hypothesis. So what have we seen? First, the ancient city of Lima has relied upon fresh water for hundreds of years. If the flow of water had stopped at any point, there would have been civilization collapse. Second, we saw large valleys carved out by glaciers. This required enormous natural forces. We're talking about glaciers needing enough power and time to create new landscapes. Third, glaciers are strange beasts where high in the mountains you have accumulation zones and low on the mountains you have melt zones. But how can these processes keep happening without the accumulation zones growing out of control and the melt zones completely disappearing? Our solution has to satisfy those three realities. But how? Whoa, gravity, sliding downhill. What if the glaciers are continually sliding downhill? What I'm saying is, what if the snow in the accumulation zone slowly slides down into the melt zone? The snow in the melt zone is replaced by snow above. I might not see or feel this glacier move, but what if it's like a slow-moving caterpillar or a giant conveyor belt moving downhill, powered by gravity? So does our hypothesis satisfy our observations? Well, it would create a way for glaciers to be grinding away at landscapes all the time. It would explain why accumulation zones aren't swelling and why melt zones haven't completely gone away. Last, because part of the glaciers would always be melting, rivers would be continuously flowing and supplying water to Peruvian cities and towns. This is so exciting. In science, this is where we either create an experiment or go out into nature looking for evidence. Oh, this is how we learn. So off we go, scouring every corner of the mountains and glaciers to make observations that might support or disprove our hypothesis. We've ranged all over this glacier looking for evidence that the accumulation zone is moving down into the melt zone. And I think we found the precise evidence that we need to prove this right here. Check it out. Right here, we have glacial ice. But on top of this ice, we have rocks. How did those rocks get there? Magically? I don't think so. They came from above. If icy glaciers are sliding downhill, they're bulldozing past cliff walls. these icy monsters are grabbing rocks from the valley walls and carrying them downhill on their backs. It's our hypothesis that a glacier is moving downhill. It's a giant conveyor belt. So these rocks were plucked from the cliffs above. Someday, these rocks and all of these rocks will be at the foot of the glacier. When these rocks are dropped off at the bottom of the glacier, they create huge piles of stone, sometimes hundreds of feet tall. We call these piles moraines, and you can see them ringing the valley right down there. Time to see if our hypothesis is right. Hey, Mission Control. Yeah, could you call in a specialist? Thanks. Mark,
Doc Ryan.
you are the master of understanding how snow and ice can provide water to people. We were in Peru and we want to know whether what we learned is correct.
Yeah, and I've been working in Peru for a number of years, studying the glaciers, studying snow, and studying how that becomes water. So I'm happy to chat.
We wanted to figure out where Peruvian cities and towns get their water. So we traced the rivers up into the Andes Mountains. We figured out that the water's coming from glaciers. And the glaciers keep providing water because they're like conveyor belts, where snow from the accumulation zone is always sliding down into the melt zone. As long as you have an accumulation zone and a melt zone, water is melting and flowing.
Yeah, you're right. A lot of the water in Peru comes from glaciers and snow. That's cool. That's why you need to get out in the field and observe things. All precipitation in high elevation areas starts as snowfall. That is, the water that falls out of the sky is snow because temperatures are below freezing. If it doesn't warm up enough to melt the snow, that snow accumulates year after year after year and becomes glacier ice. So all glacier ice started as snowfall. And so the ice in that glacier is decades old, maybe hundreds of years old, maybe thousands of years old, whereas snowfall is just a couple of months old.
So as long as there's fresh snow and glacial ice in the mountains, Peruvians will have water.
And that's the catch, is there's still going to be snow and glacier ice in 40 years, in 50 years, in 100 years. And in terms of climate change, that's really important to understand. What's happening is we are losing our glacier ice. And particularly in Peru, some of the highest rates of glacier retreat are occurring in Peru, the Cordillera Blanca, and that whole region. As the glaciers melt initially, you actually get more water, right? Because you have your snow melt, and then you're adding to it that stored fossil water that's glacier ice. But once the glaciers get really small, you lose that fossil water, and you're going to get a lot less usable water.
You're saying that warming global temperatures are shrinking glaciers and therefore threatening the fresh water that Peruvians need for life. So what we saw, explored, and learned applies to a lot of important stuff. Mark, thank you so much for your time. During our adventure from the city of Lima to the icy peaks of the massive Andes Mountains, we figured out that's the continual accumulation and melting of faraway glaciers that provide citizens of Peru with fresh water. Without these faraway glaciers, civilization in Peru and many other places would be impossible. But glaciers are really sensitive to our planet's temperature. A little cooling, and the glaciers grow. A little warming, and they shrink, maybe even disappear. With global warming, the existence of these life-giving glaciers is threatened, and with it, the lives of the people who depend upon them. When we understand the ins and outs of our world, we're given enormous power to invent, strategize, advance, and make really important decisions armed with information. On to our next adventure in science.